we're dividing by a complex number or an imaginary number. Whenever you have a monomial is when you have a term with no plus signs or minus signs, right? So here, this is a 4 minus 2i, so that's not a monomial. But the denominator is still a monomial, even though that's a negative sign, not a minus sign. It's a negative sign, all right? So what I'm going to do, if you have a monomial denominator and it's a real number, you're going to multiply by the imaginary number. The rule is kind of like the rule of no radicals in the denominator. You can't have I in the denominator. You multiply that, you get 3i, 5i squared. But don't forget, what does that I squared do to that 5? Makes it negative 5. Okay. Some teachers don't like fractions to have a negative on the bottom. You can put it up top, or you can put it in the middle. I personally don't care. I'm okay with the first one. B, you're going to multiply top and bottom by I, because we have an I in the denominator. So that's going to be 4i minus 2i squared over negative 3i squared. What does that I squared do to the denominator? It makes it positive. The minus 2i squared becomes plus 2. Remember, I squared changes the sign. Again, some people don't like the imaginary part being first. I personally don't care. All right, here we go. See? So this is the first one where it's not a monomial denominator. To get rid of that binomial denominator, you're going to multiply by the conjugate. You're going to multiply by the conjugate. So that was the whole point of the exercise we learned earlier about multiplying by the conjugate. Remember, every time when we multiply by the conjugate, there were no I in my final result. That's why we need to multiply by the conjugate here. So I'm going to multiply by the conjugate, which is 3 plus 2i. So 4i times 3 is 12i. 4i times 2i is 8i squared. The shortcut, 3 squared is 9, plus 2 squared is 4. Remember, that plus comes from the fact that I squared turns the negative to a plus. That works every time because you're using the conjugate. Clean that up. 12i minus 8 over 13. I cannot reduce this because 13 is a prime number and nothing, so it has nothing in common with these guys. D, 1 plus I, so I'm going to multiply by the conjugate, 1 minus I. Right? I had a 1 plus I in the denominator. I'm not allowed to have I down there. So I multiply by the conjugate of 1 plus I, which is 1 minus I. The numerator, I have to do it longhand because those two are not conjugate. I can't take a shortcut. So I do 9 times 1 is 9. 9 times minus I is minus 9i. Now I do the negative 2i. Negative 2i times 1 is negative 2i. And then negative 2i times negative I is plus 2i squared. Denominator is 1 plus 1. Remember the shortcut? You square the first term, square the second term, and put a plus between them. Right? So, and I'm thinking about, when I say square the second term, I'm really thinking about the coefficient of I. Coefficient of I here is 1, so 1 squared is 1. So that's how I'm getting the 1 plus 1. Clean up the numerator. I have 9. You can combine the 2 in the middle, so that's negative 11i. Remember, the 2i squared becomes a minus 2 because of the I squared. Denominator is 2. 9 minus 2 is 7. So 7 minus 11i over 2. Right. 9 minus 2 is 7. And we have E. All right, conjugate is 5 plus 2i. Conjugate denominator, that is. Multiply it out the numerator. You got to do it longhand. 3 times 5 is 15. 3 times 2i is 6i. 3i times 5 is 15i. And 3i times 2i is 6i squared. Multiply 5 times 5, 25, plus 2 squared is 4. Continue. 15 plus 21i minus 6 over 29. Right? That minus 6 comes from changing the I squared into a negative. Clean that up. 15 minus 6 is 9 plus 21i over 29. Final answer. That's it. And that's the end of complex numbers. Have a good Thanksgiving.